TVR occupies a unique and distinguished position in the automotive landscape, with a reputation unlike any other company. However, the company's reliance on the rubber V8 engine eventually prompted its management to seek out the expertise of Melling consultancy design to develop a new power plant, the TVR Speed 8. Subsequently, MCD was tasked with developing a 6-cylinder engine as well to serve as an entry-level option for TVR models. Drawing inspiration from vintage Japanese motorcycles, Melling's design was initially met with praise. Nevertheless, TVR's stubbornness resulted in engine design deviations, ultimately leading to many issues with the 6-cylinder. While some believed that Melling's design was flawed, a closer inspection of the engine blueprints revealed that the original concept was indeed exceptional. Sadly, a few unfortunate decisions ruined its reputation in the eyes of customers. Initially, Peter Wheeler, the then TVR owner, expressed skepticism about Melling's claims that the V8, the first Melling engine for TVR, would produce the promised power output. Consequently, the TVR Speed 8 was exclusively fitted into the Cerbera, which was the only model able to handle that much power. However, the Cerbera not only served as an ideal platform for the new V8 engine, but also served as a prime testing ground for the upcoming smaller unit, as it was also the first model to receive it in production. To clarify, it should be noted that although some similarities existed between the AGP6 and AGP8, the V8 was not the basis for the new 6-spot. However, the Speed 6 featured aluminum materials, a dry sump oiling system, and an overhead cam valvetrain, all of which were similar to the V8 engine. The straight 6 engine was designed to be cheaper and more practical for road use, as opposed to the high-performance flat-plane V8 that was meant as the flagship variant. MCD engineered the engine to have a relatively large displacement for a 6-cylinder, with plans for it to be available in both 3.5 and 4-liter variants. The aluminum engine block was slanted at a 15-degree angle to achieve a lower center of gravity, and the 7 2-bolt main bearing caps housed a crankshaft. The cylinder head design was inspired by the air-cooled Suzuki GSX-R from the 1980s and 1990s, featuring a twin-cam head with 4 valves per cylinder and a finger-follower actuation system that was first introduced on the Jigsaw. This innovative system, which was lighter than the bucket-style tapeheads, was crucial in developing a high-performance engine with fast revving capabilities. As a result, the Speed 6 engine delivered remarkable power and torque figures, with peak power achieved at 7,000 rpm. Notably, the Speed 6 was the first 4-valve engine in the TVR's lineup, which significantly increased the engine's volumetric efficiency. Its design, including individual throttle bodies, closely resembled that of the BMW S54 engine, which was also developed around the same time. The engine boasts several noteworthy characteristics, such as the employment of forged steel connecting rods, slipper-style lightweight pistons, and thin-wall steel cylinder liners. Interestingly, these pistons were originally designed for use in the Rotax engined Aprilia RSV 1000, but rejected, and subsequently found a home in the TVR engine after undergoing machining. The crankshaft, constructed from nodule iron, was fully counterweighted at the factory. However, the large bores of 96mm necessitated a very long crankshaft, and that introduced a few issues. In addition, other deviations from the original design have also been known to cause difficulties. It has been reported that the relationship between TVR and MCD became fraught, and to make matters worse, TVR decided to make significant alterations to the original blueprints. A guy under the name Davies of R&D Engineering acquired these MCD blueprints and compared them with the production items. There are far too many differences between them. Among these, the use of a billet steel crankshaft was abandoned in favor of one made from cast iron, with the resulting component measuring a lengthy 787mm or 660mm between the main seal internally. The new crankshaft exhibited excessive torsional vibration, giving rise to problems early on in production. To counter this issue, TVR introduced a fluid harmonic damper. Regrettably, the modification of the main and rod rollers gave rise to imbalance between the reciprocating mass of the rod's small ends and the rotating mass of the rod big ends, necessitating the addition of a 5 kg damper, an undesirable weight on a race-like engine. Furthermore, the main caps were only doweled, unlike Melling's registered and doweled ones, a decision that did not offer adequate support according to Davies. TVR enlarged the original 3.5 litre to 3.6 litres and made significant changes to the conducting rods that deviated considerably from the blueprint. The oil filter was relocated and 2 out of 4 cam feeds were removed, specifically from the exhaust side, while the 4 feeds in the original design served to provide as much cooling and lubrication as possible. In the production engine, the heated oil from the intake camshaft had to travel to the exhaust side and down the engine instead of cool oil directly cooling the hottest part of the head. In addition to these changes, the billet cams of the MCD design were replaced with hollow, sintered versions that possessed less aggressive duration and lift, while the position of the cams remained unchanged. Valvetrain geometry modifications were made to the finger followers and the follower shaft. In contrast to the Melling engine, the followers of the production engine exhibited slower acceleration, greater side load on the valve stems, and an additional weight of 8 grams per unit. It is worth noting that a dyno chart, simulated by Davies, indicates that the 3.5 litre engine made under Melling's original design would yield exceptional power output exceeding 400 horsepower and 430 Nm of torque. The valvetrain drive of the engine was undeniably robust, employing 4 timing chains for driving the alternator, AC compressor, water pump, oil pump system, and twin-row main engine chains, with one from the crank to the freewheel and the other from the freewheel to the camshafts. Despite its durability, the heat and lubrication management alterations implemented by TVR were ill-advised, resulting in detrimental consequences. Furthermore, the cooling of the cylinder number 6 was negatively impacted, potentially causing a scored bore. The production finger followers proved to be a weak component and were responsible for several issues. As a result, many warranty claims were filed against TVR, indicating a lack of durability in the valvetrain. The TVR Speed Six was originally intended to serve as a base engine for a range of upcoming TVRs, but it deviated greatly from its intended design. Initially, the plan was to have a 3 litre and a 3.5 litre engine, but later it shifted to a 3.5 litre and 4 litre configurations, although the production variants ultimately differed from these plans. Like the AGP8, the engine was designed by Melling with a focus on racing-inspired performance and high output, achieving almost 100 horsepower per litre from a naturally aspirated engine, which is no small feat and requires meticulous engineering and designed for reliability. Unfortunately, TVR made numerous changes to the original design, possibly for cost effectiveness and simplified production, resulting in various complications. David Davies of R&D Engineering conducted a thorough examination of the original blueprint and observed numerous deviations from the Melling's design in the production engines. I'm grateful to him for providing consent to use his findings. If you find my work interesting, I would be very thankful if you support this channel through Patreon website. Feel free to share your opinion about the engine down below, and see you in the next one. Cheers!